Okay, so this video is on section 10.3, which is basic probability stuff. And my guess is you've probably seen some of these things before. And when I say basic probability, I really mean pretty simple stuff. Like a typical problem that's described at the very beginning is, let's say you're rolling a standard six-sided die, and you want to figure out, well, what's the probability of rolling a 5? Well, that's 1 out of 6 possibilities, and if the die is not like a weighted die where certain numbers come up more often than others, well, then you've got a 1 in 6 chance of rolling a 5. So you would write something like this. I'll highlight it. You would write 1 out of 6, 1 over 6, or you could write it as a decimal, or you could convert it to a percent. And then the way you would write it is the probability of rolling a 5. So P of 5 equals 1/6, or the other forms there. And if I just say the probability, then it's assumed that you're not actually rolling a die several times and then figuring out how many times that number came up. Instead, you're doing it in theory. So it's called, if I just say probability, then really what we're saying is, in theory, what's the probability of it? There's something else. If you actually roll a die like 1,000 times and then see how many times 5 comes up, that instead is related to something called experimental probability, which is based on an actual experiment that you did. So we'll come back to that at the end. So let's take a look. By the way, this formula, you can memorize that formula if you want, theoretical probability. The probability of something happening is the number of ways that something can happen divided by the number of ways that anything can essentially happen. So, when you roll a die and you're hoping for a specific number, well, then it's 1 outcome divided by 6 possible outcomes. So, okay, so let's take a look at some of these problems. So 1A down here, you're rolling a standard die, so it's 6 sides, so there's 6 outcomes total. And what's the probability of rolling a 2? Well, probability of rolling a 2 is going to be, well, that's only one number out of 6 possible. That's 1 out of 6. Okay. If you wanted, you could say, or it's 0.167 or 16.7%. Right. What's the probability of rolling an odd number? Probability of an odd number. Well, that's the same thing as the probability of rolling a 1 or a 3 or a 5. Well, the probability of that, well, there are 3 outcomes in that thing called an event, the event of rolling an odd number. So if there are 3 outcomes of odd numbers, and there are 6 total outcomes, well, then you've got a 1 in 2 chance, essentially, of rolling an odd number. So you could say or 0.5 or 50%. Right? Rolling a number less than 6, well, probability of less than 6 really means the probability of a 1, 2, 3, 4, or 5. Well, and the probability of rolling that, well, you got 5 outcomes in that event out of 6 total outcomes, so it's 5 out of 6. Or if you convert that to a decimal, it's 0.833 repeating, or 83.3%. Rolling a 7, well, a standard die only has 1 through 6, so the probability of rolling a 7, there are no possible ways of doing that out of 6, which is just 0. So you could say 0 or 0%, which should make intuitive sense there. Okay, so let's look at 2. So suppose you got 7 musicians and they're going to perform at some talent show. What's the probability that they're going to perform in alphabetical order? Okay, well, there's only one way to alphabetize them. So probability of alphabetical order. Well, there's only one way of doing that. You can't have more than one alphabetical order. So there's only one way of performing in alphabetical order. And then you need to figure out how many ways are there to actually arrange the 7 performers. So number of ways of arranging the 7 performers. Well, this right here, that's 7 permute 7. You're taking 7 objects and permuting them, taken all at a time. And that's the same thing as 7 factorial over 7 minus 7 factorial, which is 7 factorial over 0 factorial, which is 0 factorial is 1, remember, so it's 7 factorial. So this whole thing here, I'll kind of do a little bubble here. So this whole thing is 1 over 7 factorial. So let me use the calculator to figure out what this is. Oh, no. So clear that. 1 divided by 7, and then I'm going to go to math and scroll over to probability and choose option 4 for factorial. Enter. Now that's a tiny decimal. So that's going to be, that's a times 10 to the negative 4th right there. So this comes out to be, or if you just did 7 factorial, it'd be 5040. And then that comes out, here, we'll do it like this, 1 over 5040. That might give me the same form, I'm not sure. Yeah, it does. But that's 0.00198, 0.000198. Or if you move the decimal over a couple places, it's 0.0198%. So it's very, very small percentage. All right. So let's say you have to pick a number from 1 to 20, and we'll say inclusive, which means 1 and 20 are also part of those. You could pick 1 or 20. If you say non-inclusive, then it's really any number starting at 2 up to 19. So you pick a number from 1 to 20. What's the probability that it's a factor of 3? Well, that's really the probability that a factor of 3 would be 1 or 3. Right? Those are the only factors of 3. So if it's 1 or it's 3, then there are only 2 options out of 20. So you get a 1 in 10 chance. Right? Or you could say 0.1 or 10%. Okay, what's the probability that it's a perfect cube? Well, perfect cube means, 1 cube, 2 cube, 3 cube. So it's the probability of it being 1, which is 1 cubed, or 2 cubed, which is 8, or 3 cubed would be 27. You could keep going, but any number bigger than 20 isn't going to count. So as soon as I get 27, I'm done. So that's actually 2 out of 10, 20 also. So 1/10, which is or 0.1 or 10% again.
My bad, I forgot a lunch.
Sorry about that. Somebody just walked in. Anyway, okay, so that's that. Let's see. Let me do another one for A. Let's say it's probability that it's a multiple of 3. So that would be probability that it's 3, or it's 6, or it's 9, or it's 12, or it's 15, or it's 18. And then if you got to 21, well, you're already past 20, so that doesn't count. So you got 1, 2, 3, 4, 5, 6. We got 6 out of 20, which is 3 out of 10. So that'd be 0.3 or 30% if you wanted to write it this way. Okay, let's take a look at 4. Cereal company has 5 cereals, and they're all different, and each one has a different price. So what's the probability that they'll be introduced in order of price? Okay, so order of price, well, there's only one way that you can put them in price order, right? So let me write this. Probability order of price. So we've got one way of doing that out of, and then there's going to be several ways of ordering 5 objects. So we want number of ways to arrange the 5 cereals. Well, that's really 5 factorial, or 5p5, right? 5 permute 5. So it's 1 over 5 factorial. 5 factorial is 120. So it's 1 out of 120. Or you could say, if you turned it into a decimal form, 00833 or if you move the decimal 2 places, it's 0.833%. The 3 is actually repeating. What's the probability that the multigrain is the one that gets introduced first? Well, on that one, probability of multigrain first. Well, there's only one way to introduce multigrain first. And really, we're saying out of how many different choices do you have to introduce first? Well, you got 5. So you got a 1 in 5 chance. Okay, so I got interrupted again, and so I paused it. I think I had just said the probability of the multigrain being first was 1/5, because there are 5 total things you could introduce first, but only one of them is multigrain. Or you could convert it to 0.2 or 20%. Right? All right. So then there's this other thing called odds, and I think the mistake a lot of students make is they say odds and probability are the same thing, but they're actually not. Like if I said there are 50-50 odds that it's going to rain today, that's not 50 over 50 equaling 1. That's not a 100% chance of rain. It's a 50% chance of rain. If I said is 40-60 odds, that's a 40% chance of rain. So it's really what's the chance of rain over what's the chance of no rain. So that's kind of the idea. So it's outcomes in A over outcomes not in A. That's how you get odds. So, and you can also write, you can write, you know, if the outcomes in A is little a and the outcomes not in A is little b, you can write A over B. This is also a common way to write odds, A colon B. So it's a ratio still. So let's say in number 5, you're drawing from a standard deck of 52 cards. So remember there are 4 suits, diamonds, hearts, clubs, spades, and there's 13 types of each card. So 13 like hearts, because there's ace through 9, which is 10, and then jack, queen, king. So what are the odds of drawing a 10 in favor of drawing a 10? Well, there are 4 10s. There's the 10 of hearts, 10 of clubs, 10 of, you know, whatever, diamonds, and what am I missing? Spades. So there are 4 10s. And out of the 52 cards, the ones that aren't 10s, well, there are 48 of them. So it's 4 out of 48, which is 1 out of 12. And then you just leave your answer like that. You don't turn it into a decimal. Or you can write 1 to 12, like that. You've got a 1 to 12 chance of drawing a 10. Let's do C. What's the probability of drawing a 10? Well, there are 4 10s out of 52 cards. So notice the difference here. This one is how many 10s over how many not 10s. And this is how many 10s out of how many total. So this one is 1 out of 13. And if you convert that to a decimal, then it's, actually, I don't know what that is. I'm not going to worry about it. Let's just compare 1 out of 13. This one says the odds against drawing a diamond card. So that actually means the odds in favor of drawing anything but a diamond card. So how many non-diamonds are there? Well, there's 52 minus 13 non-diamonds. And then, so it's the odds of drawing a non-diamond, which means non-diamonds over diamonds. So there are 13 diamonds. So this ends up being 39 over 13, or 3 over 1. So, and for some reason, you don't get rid of the 1 there, because then it shows, well, for every 3 non-diamonds, there's 1 diamond. Or you can write 3 to 1 like this. So there's that answer. Okay, let's take a look at 6. So instead of 52 outcomes, we got 6. Standard 6-sided die. What are the odds in favor of rolling a number less than 3? Well, that's the same thing as saying a 2 or a 1, right? Well, there are 2 outcomes of that, and then we're comparing it to the 4 other outcomes that you can get. So it's a 1 to 2 set of odds, or 1 to 2. And what are the odds against rolling a 6 really means the odds in favor, of rolling a 1, 2, 3, 4, or 5. Well, the odds of rolling a 1, 2, 3, 4, or 5, that's 5 outcomes that are good over 1 outcome that's bad. So that's going to be 5 to 1. So you can write it as 5 over 1 or 5 to 1, like that. Okay, so then we've got this thing called experimental probability, which I talked a little bit about right at the beginning of the video. And that's one, it's not theoretical. You actually have to do an experiment and then figure out, based on the experiment, what it looks like your probabilities are. So what's the problem? In A, the probability of rolling a die and getting an even number, I just write probability. That means you assume the theoretical one. So getting an even number, that'd be the probability of rolling a 2, 4, or a 6. Okay, well, there's 3 outcomes there that are good out of 6 total outcomes, because it's probability, not odds. So it's 3 out of 6, which is 1/2 or 0.5 or 50%. All right. In B, we're rolling a die 10 times and then recording the data. Now, I already did this, and let's see, what did I get? I got a 4 the first time, then a 6, then a 4. I actually did do this, by the way. I'm not making this data up. 6, 3, 2, 6, 5. Okay, so let's say you rolled the die 10 times and you rolled a 4 the first time, a 6 the second time, blah, 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 down to a 5 on the 10th try. So based on the experiment, what's the probability of getting an even number? Well, probability of an even number, and remember this is experimental probability. Well, then you look at your actual outcomes. I got an even, then an odd, then another even, then an odd, then an even, then an even. So 1, 2, 3, 4, 5, 6. I got 6 evens out of 10 total rolls, 10 trials. So that's a 3 out of 5, or it's a 0.6 or 60%, right? So it's not actually the same as the theoretical probability, but you know, it turns out if you kept rolling the die and recording your data, then typically this gets closer and closer to the theoretical probability. Okay. We got one last type of probability, which is called geometric probability. So the way that this one works, well, let's say you've got a dart, and you're there are always dart problems. I don't know why, but you got a dart, you throw it at the square, and for some reason you're equally likely to hit any part of the square on the inside. You're not aiming, but you're just getting it in the square every time. So what's the probability that it's going to hit the triangle, right, the shaded region? So in order to figure that out, probability of the shaded region is going to be the area of the shaded region divided by the area of the total region. Well, the shaded region is a triangle, right? That has the 1/2 base height formula. And then the total is a square, so that's just going to be 10 times 10. And if we do 1/2 base height, well, the base of the triangle is 10, and the height of the triangle is also 10. So it's 1/2 10 times 10 over 10 times 10. Well, that 100 and that 100 cancel, so you just got a 1 out of 2 chance. Or 50 out of 100, or 0.5, or 50% chance. Okay? And then in B, we're throwing a dart at the circle, and the idea is that you're just as likely to hit any point in the circle as any other point inside the circle. What's the probability that it'll hit the shaded, whoops, I lost the D there, shaded region. So again, probability of hitting the shaded is going to be the area of the shaded region divided by the area of the total region. The shaded region is a triangle. The base is 16, and the height is half of 16, because 16 is the diameter, so the height is 8. So the area is going to be 1/2 8 times 16. And then the total thing is a circle with a radius equaling 8. So the area of the whole thing, area of a circle, is pi r squared. So it's going to be pi 8 squared. Well, on top, it's going to be 64. 1/2 8 times 16 is 64. On the bottom, it's pi times 8 squared, so pi times 64. So the 64 is canceling. You're left with 1 over pi. So you could leave your answer as 1 over pi, or you could convert it to a decimal and get 0.3183. It keeps going. Or you could convert it to a percentage and say about 31%. And if you kind of look at it, it should look like the triangle here. It takes up less than half. It ends up taking up about 31.8% of the circle. All right, and that does it for the probability. That's the last major lesson of the year, and I hope that works out fine for you. All righty.